Hello, this video is to show the graphing of a rational function. We have done that last chapter, but just like to go over the importance of drawing asymptotes when you have a rational function. So this function is 1 over x minus 2 plus 3. From last chapter, we've learned that we need to do that in more than one step by first drawing the parent function, which is f of x is equal to 1 over x. So I have a grid here whose each square is 1 unit. So I'm going to draw the parent function by identifying the key points for the rational of 1 over x, which is 1, 1, 1 half 2, 2 and 1 half. And on the other side, similarly, it's negative 1, 1, negative 2 and half, and negative 1 half, negative 2. So the asymptotes of the parent function are the x and the y axes, because as we know that the domain and range, if I just write it on here on the side, domain is x such that x can't be 0, and then the range is y such that y cannot be 0. So the value or the function cannot touch the y-axis, and it can't touch the x-axis. I'm not sure if I can actually add a point. So it can't touch the y-axis right here, and it can't touch the x-axis right here. So I'm going to go ahead and draw the second half of the parent function. Just making sure my points are there. I could see them. Okay, now this one doesn't have any stretch or compression. We're actually going to just do the translation. It's only a two-step graphing. So the translation here is 2 units to the right and 3 units up. So from the values right here, x minus 2 and x plus 3, this is the horizontal translation. This is the vertical translation. So all I'm going to do then is I'm going to take each point and I'm going to move it 2 units to the right, 3 units up. Here we go. Okay, so I'm going to take this unit and I'm going to move it 2 units to the right. So now I'm in the middle of the square. Let's do that pointer right there again. I'm in the middle of a square. I'm actually going to move it to the middle once, to the middle, 2 steps to the right. And then I'm going to go up 1, 2, 3. That's what I'm really going to do with each point. Okay, so I'm not going to keep using the pointer. I'm actually going to graph. Now I'll take these points. So I'm going to have 1, 2 right here, and then 1, 2, 3. So this point right here ended up here. I'm going to do the same thing to all the points, okay? So this one, 1, 2, 1, 2, 3. And then this one, 1, 2, 1, 2, 3. Now notice that this point right here, when I moved it up, so I moved it first 2 units to the right. When I moved it 3 units up, it ended up 3 units up. It ended up in the middle of a square as well, because it was originally in the middle of a square. I'm going to do the same thing on the other side. So 1, 2, 1, 2, 3. 1, 2, and then up 1, 2, 3. And then 1, 2, 1, 2, 3. Now notice that the shape at which the points originally were on this side kind of took on the same shape on this side, and the shape at which the points were on this side took on the same shape. Sometimes if you get a point off a little bit, if you don't get the same shape, that's just an indicator that you did something wrong, and you need to go back to your points and just check like maybe you just counted wrong. Okay. So the importance now is people were missing on the assignment. They were not doing the asymptotes. So I'm going to be very picky this time, and I'm going to be looking for asymptotes on the test. And I need to make sure that you guys identify the asymptotes. So we know that the restrictions or the asymptotes from here is x can't be 2 and y can't be 3. So let me just write that down. So we know this is actually for the parent. For the transformed function, the domain is x can't be 2, and the range is y can't be 3. So what does that x equal to 2 not equal to 2 is? That is a vertical line. So I actually graph it. That is the vertical line at can't be x equal 2. And the y can't be 3. That is a horizontal line at y equals 3, right there. So people need to draw those asymptotes, which kind of helps. It helps because when you're graphing then the transformed function, you know where to level off that graph. So the graph cannot touch this line, and it can't touch this line. Here we go. So that's it. That is the graph of, now we're just going to label, of y equals 1 over x minus 2 plus 3. And this is the graph of the parent function y equals 1 over x. Thanks for watching.